Hi there, Michael here. Recently, Alejandro from Audio Brewers demonstrated how to use head tracking with their immersive audio production plugins. If you have not seen this video, I highly recommend checking that out. I'm going to leave a link in the description below. For those new to this channel, head tracking monitors the listener's head position to create an immersive audio experience through headphones. Alejandro used Apple AirPods, which have built-in head tracking capabilities. Now, if you follow my channel, you know that I value AirPods for two reasons. First, their native head tracking, and second, their ability to function as over-the-counter hearing aids, which helps those with mild to moderate hearing loss. And while AirPods might not match the studio headphone quality, their hearing correction features make them a viable option even in professional music studios. I covered this in a recent video. I'll post a link in the description below. I've made many head tracking videos in the past, available in my head tracking playlist, but I hadn't discovered the head tracking application that Alejandro used until now. Today we'll explore this software called Headitude, a free macOS application developed by Daniel Rudrich that captures orientation data from Apple AirPods and forwards it via Open Sound Control or OSC to a specific IP address and port. Specifically, we will use Headitude in connection with the native head tracking functionality that is built into the Dolby Atmos renderer and also in the latest Cubase version. And we will see that Headitude offers a few unique features that arguably make it the best head tracking application available today. But enough said, let's get started with Headitude. Before we begin, a quick note. Apple AirPods head tracking only works within the Apple ecosystem, specifically requiring an Apple Silicon Mac. However, Headitude's design allows Windows-based studios to use this setup by incorporating an Apple Silicon Mac sort of as an audio interface. So Windows users might want to stick around to see if this would work in their studio. If there's enough interest, I may create a detailed video about a Windows setup. I hadn't discovered Headitude earlier because it cannot be downloaded in binary form. It requires that you compile it yourself, but don't worry, compilation is extremely straightforward and I'll guide you through each step. Since Headitude is a Swift application, we first need Apple's Xcode development environment. So the first thing that you need to do is to download and install Xcode from the Apple App Store. Note that this is a large download, but it is completely free. And actually everything that we're going to do today is completely free. Okay, and with that, let's now download the Headitude source code from GitHub. And as always, I'm going to provide a link in the description below. Now, there are many different ways on how you can download source code from GitHub. If you're familiar with GitHub, just clone the repository. If you're unfamiliar with GitHub, don't worry. The easiest way is to just go here to code and download the zip file. Download that to wherever you want your source code to live. In my case, I just downloaded that to the desktop and then unzip that zip file to get the source code. So I've unzipped that here to the desktop. So let's just open that. And if I open that, I have a couple of files. I see all the different source code files. Now, if you are not unfamiliar with programming, don't worry. We don't need to program anything. The only thing that we really need to do is we need to open up this file that's called here headitude.xcode project. And that will open up Xcode and essentially kind of give you all the things that you need in order to compile Headitude. So let's just open that, and that once again will open Xcode. Now, if you open that for the first time, there are a couple of things that you need to do, and most importantly, the system will actually ask you to log in with your Apple ID. So essentially what you need to do is in the signing and capabilities under the team tag, and once again, it's actually going to warn you that that is missing if you have not set that up yet. You need to tell Xcode your Apple ID. You can do that with a free Apple ID. However, be aware that with a free Apple ID, there are certain limitations, and I'm going to come back to that later. Then in the provisioning profile and signing certificate, you need to select one of the two options. You can either sign it to run locally or you can sign it with a development certificate. Now, if you are unfamiliar with that, what that actually does is it tells the Mac operating system that this file that you have compiled is actually kind of okay. It is secure and it can run on your system. Now, unfortunately, there are limitations, time limitations to that. So what will actually happen if you are using a free Apple ID, that the signing will only work for a week. So that essentially means that you need to recompile that every week. In order to get around that, what you can do is you can purchase a developer license, which is, I believe, $100 per year. And if you do that, then essentially it will be able to run for a longer period of time. So you only need to compile it once, and then it will work for, I think, a year or 3 years, something like that. But for what we are doing here, kind of the free Apple ID is perfectly fine. Just be aware that you might need to recompile it every once in a while. Now, one other thing is that when you open that for the first time, it will actually come up with a couple of warnings. These warnings are not really critical. You can leave them alone so that you will actually see them here on the left side. Or you can follow the suggestions that Xcode gives you and make the changes that Xcode asks you to do. And then essentially you will be able to open that without any warnings. But once again, these warnings are not critical. If you're uncomfortable making any changes to the code, just leave them alone and it will work just fine. And with that, the only thing that we really need to do is press this little button here that will compile Headitude. And once it is compiled, it will actually run it. So let's do that. And that will tell me build has succeeded and it's opening up Headitude. And let's wait until it has opened up. And here we are. And this is Headitude. It's actually a really nice interface. The developer says it's his first Swift application, and I have to honestly say it's a really nice one. It's also programmed very well. The only thing that I would say is that the documentation could be a little bit more complete, but the code is written really, really well. The Swift application actually is really nice. So if this is really your first application, congratulations. And with that, what we now need to do is we need to kind of put on our AirPods. And as soon as I put on the AirPods, it will actually tell me that it's connected. And as you can see, you see this little head here. And I actually like the way this is visualized. Usually what you see is a weird dummy head, and I don't like that. This is actually really nice. It's kind of really nice. Now, when you do that for the first time, one thing that you need to do is you need to go into full calibration. And the reason you want to do that is because the application doesn't actually know how exactly you wear your AirPods. And that essentially means that it doesn't really know exactly where the vertical direction is. So what you need to do is you need to press this full calibration button, then nod, and then kind of release it, and that will tell the application the vertical direction. So let's do that. Let's press full calibration. Then I'm nodding and I'm releasing it. And once I've done that, it will actually kind of know exactly what the vertical direction is. If I ever drift and that is not working anymore, I can always set reset orientation, and that will kind of reset it. Oops, now I reset it to the wrong direction. So here we are. And that will always kind of be able to reset that. Now, one thing that is particularly nice is the fact that this is the only AirPods head tracking application that I know that actually maintains the direction. What do I mean by that? Usually, if you wear your AirPods and you work with one of the plugins that are available that allow you to track the position of your AirPods, what will happen is that if you move your head to the side, for example, after a while, the plugin will recalibrate and will now assume that this is your forward direction. However, in a situation that we are in, this is not ideal because the computer that I'm working with is always going to be on a particular side. Now, what Headitude does, and once again, this is the only application that I know that does that, it will actually not recalibrate. It will actually leave the position alone. So that means that if you are working in an immersive environment, if you're working with immersive audio and you want to just kind of check, does everything work okay, you can actually leave your head in that position for a while. And it will not recalibrate. And that's actually really, really nice. So this is a very unique feature that makes this feature alone, quite frankly, makes this my favorite head tracking application, because this is so nice. Now, if you're a little bit confused about the fact that this is looking directly at you, you can also toggle the view. And if you do that, you will sort of see your head from the back. I'm not quite sure why you want to do that, but kind of if you want, you can. So let's look at the OSC or Open Sound Control settings, because that is actually really, really nice by itself. So the way this is implemented is also relatively unique, and it will and extremely flexible, and it will actually allow us to do certain things that we can't do with other head tracking applications. So let's have a look. Now, first, let me toggle that back. I like to watch this. I like to watch this little kind of sphere thingy. I think it looks really, really nice. Now, here in the OSC settings, there are a couple of things that we can set. First of all, we can set the host IP, and that essentially means that we can send the OSC messages from these applications to an external computer. And this would allow us to use that in connection with a digital audio workstation that is Windows-based, for example. So what we could do, for example, is have everything, the audio workstation and everything Windows-based, and then essentially use a Mac as sort of an audio interface that just has the purpose of connecting to your AirPods, taking the head tracking information, then sending it to the IP address where your digital audio workstation resides. And then the audio workstation would have to send the audio back to your Mac, and you would then hear that through your Mac. So in some sense, really, you would use a Mac as an audio interface. And that would work, actually. I've honestly not tried it yet, but there's no reason this should not work. And this should actually work with a very, very kind of basic Apple Mac. The only thing that Mac would need to be is it would need to be an Apple Silicon Mac, because Headitude requires that you're working with an Apple Silicon Mac. But what you could do, for example, is you could buy a used M1 MacBook, the cheapest you can get, and then simply use that as an audio interface. Now, if you're really interested in showing me and me showing you how to do that, let me know and I can make a video about that. It's actually something that interests me. I might actually do a video regardless. So even if you ask me in the comments, but if you ask me in the comment section, I will more likely make it earlier. In addition to the host IP, you can also set the port. That is important for certain applications, because some applications require you that the OSC messages are sent to a specific port. This is by default set to 3001, but you can set that to anything that you want or that you need. And we're actually going to kind of change that in a second. And then you can, and that's also another really nice feature, you can define what the actual OSC messages is going to be. And this is extremely useful because it allows us to customize the messages that are sent from Headitude to the specific needs. And this will actually become really important for us when we are going to use Headitude in connection with Cubase, because Cubase requires a very, very specific message format that almost no other plugin can actually handle. So this is actually really, really nice. It's a super nice feature, and I'm not quite sure why nobody else implemented it that way. The flexibility here is really unique and makes it super useful. Okay, so now let's have a look on how to actually use that in connection with some particular pieces of software. And I'm going to show you how to use that in two use cases. In the first use case, we're going to work with the Dolby Atmos Renderer, which has native head tracking capabilities. Not a lot of people know that, but you can actually use head tracking in connection with the Dolby Atmos Renderer. And the second one that we're going to use is Cubase, and the same works also for Nuendo, but I'm going to show it to you in Cubase. So let's start with the Dolby Atmos Renderer, and the first thing that we need to do is we need to set up the Dolby Atmos Renderer for head tracking, and that is actually really simple to do. Let's just go into the preferences. In the preferences, we need to first of all make sure that the headphone render mode is set to binaural, and then we're going to simply say head tracking on, and that will enable head tracking capabilities in the Dolby Atmos Renderer. Now, depending on what software you have installed, so for example, if you're working with the Odyssey Maxwell headphones, they actually work together with the renderer, with the Dolby Atmos renderer. You might have different options here. The one that you want to choose here is the OSC head tracker. If you just have installed the Dolby Atmos renderer, that's actually the only option you're going to have. But once again, if you have multiple options, just choose the OSC head tracker here, and let's say accept. And then I'm going to just kind of make a couple of changes to the interface so that we have a little bit of a better view of what's actually happening. The first thing that I'm going to do is I'm going to switch the view to person view, and that will open up the head. And then in order to see better what's actually happening, I'm going to kind of just make that larger. And this is the head. Now, The final thing that we need to do is really kind of set the parameters in Headitude in such a way that the Dolby Atmos renderer is receiving them. And for that, there are a couple of things that we need to do. First of all, we need to set the port to 8000. So let's do that. And then we need to set the message format from scene rotator, yaw pitch roll to simply yaw pitch roll. As soon as I do that, we will already see the head in the Dolby Atmos renderer moving. However, it's moving in the wrong direction. As we can see, the yaw is wrong. So if I'm moving my head to the left, essentially the dummy head is moving to the right. And the same is also for the pitch. The roll is okay. So all we really need to do is we need to change the sign for the yaw and the pitch. So let's do that. We have here minus yaw and minus pitch. And as soon as we do that, everything works fine. And we now have the Dolby Atmos renderer driven by Headitude, and we can work with, kind of head tracking in the Dolby Atmos renderer, and everything works perfectly fine. So let's look at the second use case, and that is together with Cubase. And as I said before, it works with Noendo in exactly the same way. Now, I'm not going to use any audio today. I'm just going to show you how to set that up. And in Cubase, the head tracking is set up through the studio settings. So here in the studio settings, we need to go to head tracking. And in the head tracking, what we need to do is we need to select the head tracking device. And the head tracking device, what I want to set is here under Network OSC Server. And then we're going to simply say enable head tracking, and that will enable head tracking. So the last thing that we need to do is we need to set Headitude, the message format in Headitude in such a way that it will actually reach Cubase. The first thing that we note is that it expects port 7000, so we need to do that. And then we need to just set the correct message format. Now, this is rather unique because Cubase uses a very specific format that is called a head pose format. And what is unique about that is that it doesn't expect just 3 parameters, yaw, pitch, and roll, or even 4 parameters that you would have, for example, if you use Quaternion notation. But what it expects is actually 7 parameters, and the first 4 parameters correspond to the position of the head, x, y, z coordinate in homogeneous coordinates, if I'm not completely mistaken, and then yaw, pitch, and roll. So it expects 7 parameters instead of 3 or 4, and because Headitude has this flexibility, we can actually set that up to work with Cubase natively, and this is what we're going to do now. So let's go back to Headitude, and in Headitude, first of all, we're going to set that to port 7000, and then we need to set that to head pose. Then we need 7 parameters. Now, yaw, pitch, and roll are the final 3 parameters, and it doesn't actually matter or make any difference whatsoever what the first 4 parameters are. You could set them to 0. However, Headitude only allows certain tokens to be used, so it can either be yaw, pitch, and roll, or minus yaw, pitch, and roll, and a couple of other things. So what we want to do is we just want to give head pose 4 parameters. It's not going to use them anyway because Cubase is actually going to ignore that. And the best way to do that is simply using the Quaternion. Why Quaternions? Because in the Headitude application, Quaternions are kind of extracted from the head tracking of the AirPods natively, and yaw, pitch, and roll actually have to be recalculated. So if we are using yaw for the first 4 parameters, for example, so we could, for example, use 4 times yaw, it will actually calculate it 4 times, and that is just not necessary. So what I'm going to do is I'm simply going to here use QW, that is the weight of the Quaternion. Once again, Cubase is going to ignore that anyway, and I'm going to do that 4 times. And then I'm going to set yaw, pitch, and roll, and the way Cubase expects that is actually in a different order. It expects pitch first, and then yaw, and then roll. And once I do that, and I go back to Cubase, I should already see that things are moving. Now, once again, the orientation is incorrect. So for yaw, we actually need to choose the negative raw. Pitch is also negative, and roll, once again, is actually correct. So let's go back to Headitude, and let's change the pitch to minus pitch, and the yaw to minus yaw, And as soon as we do that, essentially it is already kind of giving me the correct kind of positioning. So if I look at yaw, pitch and roll, the way it arrives at Cubase, yaw, pitch and roll. And with that, we have Headitude natively connected to Cubase. Once again, it doesn't actually make any difference where Headitude is. It could be on a different computer. So if you're using Cubase on a Windows machine, for example, just use a separate Mac to do the head tracking and send the information into Cubase. And that works actually really, really well. Now, one thing that I need to point out is that at least in earlier Cubase versions, there were some issues with the performance when you used external head tracking. So if you set it up like I do and you see that Cubase is stuttering a little here, it's not as smooth as it is with me. This is completely smooth, so this is perfectly functional. But it's actually stuttering a little. What you would need to do is you would need to reduce the rate with which Headitude is sending OSC messages into Cubase. Now this can be done, however, it would require us to actually change the source code. I'm not going to do that in this video, but if it happens to you and you want me to show you how you can actually change the source code in such a way that it doesn't send as many OSC messages as it is sending right now, then just let me know and I can create a video about that. But for kind of in my particular case, this was actually perfectly fine. I had no issues whatsoever. I'm working with an M2 Mac and I'm having Cubase here and it runs perfectly fine. Well, that's everything I wanted to talk about today. As always, if you have any questions, either leave them in the comment section below or join our free Discord server. An invite link is in the description as well. There are many helpful people there that can help you with almost any question that you might have. And don't forget to subscribe to this channel to stay updated about anything related to immersive audio production. And with that being said, I'll see you all in the next video.